Okay, if you've made it to this video, you're probably trying to analyze some samples that you just ran on the GCMS. In this video, I'm going to show you how to make a compound list where you've determined which compounds you want to include and analyze from all of your different samples. Okay, briefly, I'm going to show you how to do this in this software called Enhanced Data Analysis. And what you'll want to do is first find this software on the computer that you're using. The symbol looks like this right here. And once you have opened the software, it should look something like this. What you'll need to do next is load the sample that you're trying to use. So in this case, I have all of the samples that I'm interested in inside of one folder. So you'll click on that folder and press OK. And you should see all the different individuals that vials that you've run on inside of this folder. So just open any one of them. In this case, I'm going to choose this one. And what we want to do is start to figure out what compounds are inside of each sample that you are using to make this compound list. So to do that, we're going to change some integration parameters. And what you're going to want to do is go to chromatogram, go down to MS signal integration parameter, like you see right here. And it should look something like this. If this is not what's coming up on your screen, wait till the end of the video and I'll show you how you can get back to this RTE integrator parameters. And what we want to do is determine a minimum area peak that the software is going to use to integrate these peaks that you're seeing here. So each one of these peaks should be a compound that you might be interested in. In order to zoom in, I have left-clicked and drawn that or traced that box. And to get out, I'm going to double left-click until I'm back to where I am. All right, so what we're going to do is start out looking at changing this number right here to determine what area we need to integrate at. So I'm going to press apply. And if I think I'm getting too many small peaks, I'm going to start increasing this number here until I think that I have minimized all the noise that I'm getting in my sample. And this will vary based on what type of sample you're running and what exactly you're looking at. So you're going to have to determine this number based off of your samples. So once you are happy with that, you're going to save this integration parameter that you're setting. So you'll click here on save and press OK, and it will prompt you to rename this file. And you can save it wherever you want. So in this case, I'm running volatile analysis. So I'm going to save it as VOC integration. And you'll press OK. And now that it's saved, I'm going to click here and press OK. All right, so you've just set some integration parameters based on areas of these peaks. In order to set up a method now to pull out the retention time and the name of each of these peaks, we're going to go back over to method and we are going to edit the method. Okay, you should see something like this. You want to make sure that %report and library search report are clicked. Press OK. And here you're going to sort by retention time. So retention time basically is when the compounds ran through the column. They will sort out based off of this time that you see here along the x-axis. And the y-axis is going to be the abundance or the amount of this specific compound. And you're going to want to make sure that the %report gets to the screen. You're going to click browse here and make sure that you've clicked on the VOC integration parameter that you just made or whatever you have named it on your computer. Press OK. And then what you need to do is upload the libraries that you're going to have the software reference back to. So in some cases, you might be really interested on exactly what the compound is, and these libraries are going to be able to refer back to it if there's that compound inside of the library already. However, in other cases, you might not be interested in the name of the compound, just that the compound appears at that specific retention time. Either way, you should still upload the libraries if you have them. In this case, we're going to put them in this order. The first one's going to be atoms 2. The next one is going to be chemical. And the last one is going to be this NIS 17. Okay, so once you've done that for all 3 of them, you will add this match here to however you want. I like to keep this at 70. All right, you press OK. And now you will make sure that only screen is checked off here. So you want to remove printer. Again, you're going to add that integration parameter file that you've already made and click OK. So you want to save the changes that you've made to the method and you'll press yes. And then you're going to name this method whatever you choose. In this case, I named it VOC method and I saved it in this file here on my computer. Okay, you'll do that, press OK. And now you have a new method which should appear right here on the top. You'll also see the name of the file that you have opened right now, and that's what this is right here. So once you have made a method, you are going to run that method for any of the individual samples that you are interested in determining what the peaks are, or determining what peaks are in all the files. So to do that, you're going to go to method, run method, and now the computer has applied this method just to this sample. So you are going to go to File, Export this data, and you want to click this one, Current File, select Destination, and press OK. Now we're going to export the library search results and press OK. And once you've done this, you need to save the file. So as you can see here, I've already done this for 5 other samples. And I'm going to save this library search report as the same name of this specific sample. So in my case, it's going to be morning HIPB1. And again, the name of that is right here. And I'm going to press open. And just so you can see what that looks like, I'm going to open the Excel file. Oops, that's the wrong one. Okay, I'm on 2 screens here. So I just named that morning HIPV1, and I'm going to open this for you. Okay, and what you see here is that this is the library search that the method automatically ran and exported for us. And what's important here is that there are different compounds or peaks that the method identified. The quality match is right here. So it can go anywhere up from 100% match to what is inside of the library, all the way down to very low match numbers. There then is the retention time at which that compound came out at. This is going to be really important here in a second. And also the area is going to be important as well later on. And then the system also provides us with a name that the peak was matched to. And for example, what I want to show you is that I added an internal standard to these samples, nonyl acetate. So I know that this is about the right retention time, and I'm very sure that this is the compound I added. However, the quality match is only 81%, and that's okay. We'll go through that in a bit. So I'm going to close this now. I'm not going to save it because I didn't make any changes. I opened that by accident, and I'll close this here as well. Okay, so basically I have just done this now for one file, and I'm going to do it for the rest of them that are inside of the folder that I have, or all of them that I care about looking at what compounds or what specific peaks are in each of the samples. Okay, so you would just do that for all of them and create several different files that have your library searches in it. And once you've come up with a compilation of these library search reports, you can copy and paste those important things that I highlighted before into one document. So I've opened a new Excel document. I have named it compound list, and I have copied and pasted all of the retention times, quality matches, everything we just went through for each of the samples that I had previously done. And so you can see here that I have created a new column next to the retention time where I have copied the sample name all the way throughout all of the different compounds that the method ran through and provided me with. And I've done this for different samples, okay? So now once I have this master list, I'm going to sort all of this in order to determine which peaks are coming up in all of my samples, okay? So in order to do this, I'm gonna select everything. I'm gonna go over to this sort and filter. So yours might look a little bit different, but basically you're going to do a custom sort. And you want to sort by this retention time. That's really what we're interested in here, okay? So you'll press OK. And what happens now is that all of the rows are sorted based on retention time, and you want to go through and look at which compounds are coming up consistently at the same retention times for all of the samples. So for example, although this one has low quality matches, the same compound looks to be coming up in these samples right here. So I'm going to go ahead and highlight this. And you'll go through and determine what compounds you're interested in and create this compound list for all of your samples. For all of the compounds that are here. And what I'm going to do is also show you that I'm really interested in nonal acetate because I know that it's my internal standard that I added, okay? So you'll have gone through and created this compound list based on retention time that you're interested in. And now I'll show you how to, once you've determined what compounds and what retention times you're interested in, how to automate this for all of your samples, okay? So I'm gonna exit here. I will open a new sample. In this case, it'll be the same one. And I'm going to try and quantitate this. Okay, to do so, I'm going to go up here to calibrate, and I am going to click on edit compounds. And as you can see here, there's already a list of compounds. If you did not make this list, you're going to want to start from scratch. So I'll show you how to clear this, and you'll click the same place, calibrate and clear. And you're going to want to clear all compounds. Okay, so now once you've done that, you want to set up an auto quant based off of a sample that has the most number of peaks that you think. So you're going to want to pick a really busy sample. And in this case, you're going to do the same thing and click no to secondary signals. We don't really care for that. All right, so now you're going to start determining this auto quant. What you're going to do here is leave everything up here the same. You're going to add the same integration parameter file we've been using. You want to leave this as area, press OK. And what the system is going to do is now start presenting you with the different compounds or the different peaks that it has identified. And you're going to go through and allow it to add it to that list that we just cleared, or you're going to skip. For the sake of this video, I'm going to skip a lot of the compounds, but you're going to make sure you go back to that compound list that you've determined all the compound that you're interested in based on retention time. So you're going to refer back to this list that you've just made. So in this case, I'm going to keep skipping most of these. Some that I want, I will click add. If it's not a compound of interest, you're going to click click skip and continue to enter. If you would like to add it, you will click add. If you want to change the name, you will click here, click add, and then rename it. So maybe I want to take that away. Press OK. I'm going to keep skipping. I'm going to skip all the way until I see a compound that I know I might be interested in, like this one, myrcene. And now I'm going to keep skipping until I get to my internal standard. But you'll want to add all the peaks that you're interested in. Okay, here's my internal standard. I'm going to add this one. And now it says that I've gone through all of the peaks that the method has identified, and now I will quantitate, so press yes. Okay, I'm going to change this level to NA and click do update. And in this case, you'll see that the system has added all of the compounds that you had clicked add to this list here. And what you need to do is now go through each compound and change this to total ion chromatograph. You want to have this computer analyze this based on all of the ions. So you'll go through and change that for each one. And if you added one by mistake and you want to remove it for your compound list, for example, this one, you can right-click on the compound and click delete current compound. And you can also manually add a compound back in. So you can right-click here and say insert a compound below. I'm not going to do that now, but you can go ahead and do that on your own. Okay, I'll press OK here and save. All right, so now that we have set up the auto quantitate, I'm going to go to the quantitate tab and click calculate. And now that it has calculated everything for me, I want to export that calculation. So I'm going to say export reports, quantitation result, report to XLS. And it will bring up this file that you see here. In a separate tab, in a separate file, what we normally do is copy the areas that you see here, which is what we're interested in. So I'll show you how I typically set up the Excel sheet over here on the side. What I do is I copy here, and I'm going to paste transpose, which is this function right there. And I like to always keep my retention times. Again, remember, I always do this in a separate Excel document, but for the sake of this video, I'm just doing it right here. Okay, these are really what I'm interested in here. And typically, I always make sure to allocate the sample name somewhere. So I'm going to say HIPV. And again, the name of the sample is 1 in case you've forgotten. Okay, and you'll go through doing this for each sample that you're interested in and knowing the areas of each compound or each peak if you're not interested in the compound name, and you'll form a huge list of different samples right here. Okay, I'm going to exit this. All right. In the event that you, well, let's load another file so I can show you. All right, in the event that you want to fix the areas under the peaks for each compound, you are going to click this Q edit right here. And so this tiny little symbol there that says Q edit, oops, file must be quantitated, okay. So quantitate. It's this one right here, quant report. Okay. If you're using 2 monitors, sometimes your screen will get split to another side. But basically, I had just clicked calc quant report, and that's what spit me to another screen. And now I'm going to click Q edit, and it'll allow me to redraw the area under the curve. Okay, so maybe it had only taken a small amount for some samples, or you wanted to check the areas in each of the reports that you had just gone through, you can redraw that. If you see this dashed line here, that's the retention time that you had put into the quantitate method there. And you can double click here and move through the sample. Okay, so maybe I had taken both peaks here on accident and you wanted to redraw. How I'm redrawing is by using my right finger, the right click, and I am dragging underneath the curve. So maybe I want to go up there. Okay, and you just want to be consistent throughout. All right, so once I do that, I'm going to click exit, press yes. And again, I'm on two screens, so it just got kicked off into the other screen. And I will go to export reports and quantitation results to XLS. All right, and this is the new areas that it had given me. And again, I would copy this and paste this into my master document that I'm working in, and then add the name, so Control-1. Okay, I hope that was helpful. I am gonna make another video if this was too fast to show you how I use more of the mouse and tools functions on this software. All right, good luck.